This is the demonstration video of the ANASTACIA use case MEC.3, a DDoS attack using smart cameras and IoT devices. In this scenario, we'll see an ICMP flooding attack towards an IoT camera, where a compromised IoT device floods another one using ICMP ping packets. The detection of this attack will be made within the same network, and the reaction will be computed by the ANASTACIA platform and sent directly to the security orchestrator using an XML-based language called MSPL. The countermeasure will be applied by the security orchestrator, and the ICMP protocol will be filtered. The main strategy here is that only ICMP traffic from the affected device towards the victim will be filtered. The deployment for this scenario is composed of 3 stages. First, an attack triggering, where we will see an emulated IoT network that contains an attacker and an IoT router will direct an ICMP flooding attack towards an emulated smart IoT camera that will act as the victim. The second stage will be the monitoring and reaction, where we will use the MMT IoT sniffer to extract raw IoT packets from the emulated network and feed them directly into the ANASTACIA chain. Finally, the reaction and deployment will actually take all the countermeasures computed by the ANASTACIA platform and will deploy them into the OSM and ONOS controller in order to effectively filter all the ICMP flooding attack that is going from the emulated IoT network towards the victim. In the attack triggering phase, we will have an emulated IoT network that contains an attacker and an IoT router. On the other side, we will have a victim that will be representing an emulated smart IoT camera. These two components will be communicated in between using an SDN controller, and in this case, ONOS. On the IoT network side, we will use an attack script in order to trigger the ICMP flooding towards the victim. On the victim side, we will start TCP dump in order to monitor the incoming ICMP traffic, so we will be able to see the packets arriving in the victim. With this configuration, the ICMP flooding attack will start to flow from the attacker towards the victim using the ONOS controller. Up in this screen we have the attacker and the IoT sniffer. In the downside we have the mitigation action service and the victim. We see that the mitigation action service has been started and we will start looking at the traffic into the victim. At the same time, we will trigger the MEC.3 attack, which is an ICMP flooding, which will go from the attacker towards the victim. At this point, we have an emulated IoT network that contains an attacker and an IoT router. We will now start the MMT IoT sniffer that will start monitoring raw IoT traffic. This software will extract security information that will be fed directly to the ANASTACIA platform. The ANASTACIA chain will be able to detect the incident and generate the proper countermeasures for the ongoing attack in forms of an MSPL file that contains the reactions to be deployed. As said before, the countermeasures are expressed in an XML-based language called MSPL. We can see an example in this slide. This example expresses a filtering rule of a denial from the source specified in this field to this destination of the ICMP protocol. So the read sense is from top to bottom. It's really easy to understand which is the countermeasure that will be deployed in the platform. In our example, we have just started the MEC.3 attack, the ICMP flooding. So the next step will be connect the router and the MMT IoT sniffer inside the IoT network. Moreover, we need to start the MMT probe that will analyze the extracted traffic from the sniffer. We also see the interface from the security orchestrator. We now see that the attack has been started and we received some packets on the victim. The mitigation action service has also generated the MSPL and already sent it to the security orchestrator. We also see the detected attack into the XLCM interface, where we can clearly see that an ICMP flooding has been detected, and some other information like the origin and destination addresses. So far, this is the deployment that we have. A compromised IoT device that is attacking towards an IoT victim. The ANASTACIA platform will send the countermeasures in form of an XML file towards the security orchestrator. The security orchestrator will use ONOS and OSM configuration script in order to deploy a new virtual firewall to filter the ICMP traffic. Moreover, it will use ONOS in order to redirect all the traffic towards this new deployed virtual firewall in order to effectively filter all the ICMP traffic that is going from the attacker towards the victim. In our example, the ANASTACIA platform has generated the MSPL file and already sent it to the security orchestrator. We see now the MSPL file has been received by the security orchestrator and its status has been changed to actually being deployed. For this particular instance of the MSPL, a new VM will be created that we can see here in this screen. This new virtual machine will contain a firewall and it will be added to the topology dynamically. These are the ONOS intents that will be used to block the attack. So the new virtual machine will actually use multiple virtual interfaces in order to effectively filter the traffic. In this case, we will use two IPv6 interfaces that will be used for incoming and outgoing traffic in order to effectively redirect and filter all the ICMP flooding attack. If we go back to the intents, we see the 18th intent in total, which are the basic ones used to redirect traffic. Two new intents will appear into this list that will represent the filtering rules of this new virtual machine. On the other side, we see that the attack is effectively filtered. We just see some packets that are still going towards the victim, and in a few seconds we will see the very last ICMP traffic that is now effectively filtered in the network.